reintroduce the idea of finding the equation of a tangent when we're given a circle. So a circle is just simply a line where all the points are equidistant away from the centre, and for GCSE, every single circle is centred at the radius. So for this scenario, I'm given a circle, but I want to know the equation of a tangent line. So I want that tangent line to be in the form of y equals mx plus c. So in order for this to be the case, I need to know two things. I need to know what my gradient is and what my y-intercept is. So I introduced 3 steps that we can do this. The first step was, if I need to know the gradient of my tangent, what I'm going to do is work out the gradient of my radius and use the relationship that my radius and my tangent are perpendicular. So we'll get onto that in a second, but I'm going to first of all work out the gradient of my radius. So I'm just going to do m subscript r. Now my radius is going to be, well, it's the difference in my y values divided by the difference in my x values. The difference in my y values, well, they always start at the origin, so from 0 to 2, it's going to be a difference of 2. And the difference in my x values, well, 0 to 2, it's going to be 2. So therefore, the gradient of my radius is 1. By looking at the relationship between the gradient of my radius and the gradient of my tangent, because they're perpendicular, they multiply together to make -1. That means if I've got the gradient of my radius, I can do the negative reciprocal, and that will give me the gradient of my tangent. So this is easier to do when it's as a fraction. So the negative reciprocal of 2 over 2, well, I'm going to swap these two numerators and denominators over. So I'd get -2 over 2. This would be a gradient of -1. So now, in terms of my tangent line, I know the gradient. I know for my tangent line, for m of t, my gradient is -1. So I'm going to use this line here, this formula, and substitute in -1. So my tangent line looks something like this. The next thing I need to know is my intercept. To work this out, I'm just going to simply substitute in my coordinates of 2, 2 into this equation. My y value is 2, my x value is 2, plus c. Rearranging, I get c is equal to 4. So therefore, my tangent line is going to be y equals, I know it's -x, and I've just worked out that c is equal to 4. So -x plus 4. So for this question, the tangent to the circle x squared plus y squared equals 8 at the point 2, 2 is y equals -x plus 4. So if you're unsure of any of those points, I'd encourage you to watch it again. However, what we're going to look at is 2 questions, and I'd like you to pause now and have a go at these questions before I run through the answers. So, thank you for pausing. This first question, again, I'm going to work out the gradient of my radius, while my difference in my y coordinates is 6. My difference in my x coordinates is 2. So my radius has a gradient of 3. Therefore, my tangent will have a gradient of -1/3, because it is the negative reciprocal. Using my standard equation of a line, I know that I'm going to get y equals -1/3 x plus c. So therefore, how do I find that value of c? Well, I substitute in my point. 6 is equal to -1/3 of x, which is 2, plus c. Rearranging that, I get c is equal to, or -2/3, add it along, I'm going to get 20 over 3. So therefore, my equation of my line is y equals -1/3 x plus 20 over 3. This would be great, you could leave it like this. However, sometimes it might want us to have all of our coefficients as constants. So what you'd have to do is multiply everything by 3 to get 3y equals 20 subtract x. And that would be perfectly acceptable. The next question was slightly different. We're given a diagram of x squared plus y squared equals 17. Point P lies on the circle which has an x coordinate of 1. So I'm looking at P, it's got an x coordinate of 1. I want to find the tangent at P intersects with the x-axis, so I'll work out coordinates of R. Okay, so to do this, the first thing that seems obvious is to look at this first line. If I've got an x coordinate of 1, looking at my formula for the circle, I get 1 squared plus y squared equals 17. I'm just trying to find my y value. It makes sense, looking where it is, that my y value would have to be 4, because 1 squared add 4 squared does equal 17. So now I've got a point on my line. So I know that here, P is equal to 1, 4. The next thing I'm going to do is work out the equation of my tangent. So to do this, I'm just going to again work out the gradient of my radius. Well, it goes 1 across and 4 up, so it's 4 over 1, which is 4. So therefore, the gradient of my tangent is going to be negative a quarter, which makes sense because it's going down and it's shallow. To find out the equation of my line, I'm just going to first of all substitute in my gradient and substitute in my point, 1, 4. Well, 1 is equal to negative 1 over 4 of my x coordinate. Oops, sorry, so 4 is equal to negative 1 over 4 of my x coordinate, which is 1, plus c. 4 add a quarter is going to be 17 over 4, and that's going to be equal to c. So therefore, my equation of my line is y equals negative a quarter of x plus 17 over 4. And this is where it's useful to rewrite it in this form. So what I'm going to do is multiply everything by 4. So 4y equals 17 subtract x. I want to know the coordinates at R. Well, I already know one of the coordinates. I know that my y coordinate is 0. Because it cuts through the x-axis, my y coordinate is 0. So therefore, I can substitute into here. 4 multiplied by 0, which is 0, is 17 subtract x. So therefore, x must be equal to 17. So my coordinates at R is 17, 0. Okay, so that brings the end of this session on equations of a tangent line to a circle. I hope you enjoyed, and if there are any parts that you need to rewatch or talk to me about, please do feel free to just come and find me. But thank you very much for watching, and I'll see you in the next video.